Yes, students, let us move on to the numericals related to beams. So here, as I told that we are having only statically determinate beams. So first I will take example on cantilever beam. Next we will take the second example on simply supported beam. It's a very important numerical. So when we are considering cantilever beam, as I told that cantilever beam is a statically determinate type of beams, because if you consider supports at A and C, at C we are not having any kind of support, it's a free, but at A we are having fixed support. Hence, it is having three unknown reactions. It's a rigid type of support. And also, what are the steps involved to solve these kinds of problems? In very first step, we are writing the free body diagram. We are converting all distributed loads into point loads, and also we are going to write the reactions. That is the first step. And second step, by using equations of statics, sigma fx equals 0, sigma fy equals 0 and sigma m equals 0, we are determining those unknown reactions. So in first step, we have to write the free body diagram. In free body diagram, we have to indicate the reactions, and also we have to reduce all distributed loads into point loads. So first, free body diagram. In free body diagram, first we are having A is the fixed support. So fixed support will generate or will produce three unknown reactions. That is VA, HA and ME and MA. And also at span AB we are having UDL. So convert that UDL or reduce that UDL into point load. We know that for UDL, W into L. W is 16, length is 2. So 16 into 2, 32 kilonewton at L by 2. So that is 1 meter, 1 meter. Total span is 2 meters. Exact half of the span, that is 1 meter, 1 meter in AB. At BC, here we are having the point load keep as it is, because as I told that the thing is in very first step we are reducing all distributed load into point load. We are keeping whatever the point load as it is. Whatever the point load as it is. This is the free body diagram. So here I have written the first thing is based on support conditions. I have written the reactions. Here it's a cantilever type of beam. Support A is fixed. Hence fixed support will develop three reactions: VA, HA, MA, and this is a distributed load. Have reduced this distributed load into point load. W into L acts at L by 2, L by 2, and this 20 kilonewton is a point load, keep as it is. 12 kilonewton is also a point load, keep as it is. 10 kilonewton is also a point load, keep as it is. This is the very first step. The ultimate aim of the problem is find these unknown reactions, these possible unknown reactions at supports. Determine reaction VA, HA, MA. That is the ultimate aim of the problem. Determine the unknown reactions at supports for the cantilever beam shown in figure. That is the problem. Here, determine the unknown reactions at supports for the simply supported beam shown in figure. Here, the unknown reactions are VA, HA and MA. So, this is the first step. Write the free body diagram. Right, indicate the support reactions, possible reactions at supports, and convert all distributed loads into point loads. The next very step is, the second step is determine VA, HA and MA using equations of statics. That is sigma fx equals 0. Summation of all horizontal forces equals 0. The sign convention is all forces acting right side positive, acting left side negative. Here how many horizontal forces? Only one. That is HA equals 0. HA equals 0. Next apply sigma Fy. all summation of vertical forces equal to 0. It's the equations of equilibrium. So upward forces are positive, downward forces are negative. It's a basic assumption, sign convention. So here how many vertical forces in a cantilever beam? So VA acting upward positive, minus 32 acting downward towards gravity, that is negative, 20 acting towards downwards, negative, 12 acting downwards, negative, 10 acting downwards, negative. Therefore plus VA minus 32 minus 20 minus 12 minus 10 equals 0. We are getting VA 32, 52, 64, 74. Right? So if you take on right side, it will become plus 74. 74 kilonewton. Vertical force positive. Therefore, acting positive means upward direction. Whatever we assumed, initially we are assuming reactions in positive direction. So whatever the assumed positive direction is right. Next, you take sigma moment at A equals 0. Take clockwise moments are positive, anti-clockwise moments are negative with respect to this point. So MA is already present as a moment. So take this is a clockwise of whatever we assume, that is clockwise. Therefore plus MA plus MA. So and this 32 towards A rotating in clockwise direction and perpendicular distance is 1 meter. Therefore plus 32 into 1, that is rotating in clockwise. Hence I have taken plus. And this particularly this 20 with respect to point A rotate towards A in clockwise. The perpendicular distance is 2 meters. That is plus 20 into 2. It's also clockwise. Hence plus. Next this 12 rotating towards A. The perpendicular distance is 2 plus 1, that is 3 meter. 12 into 3 plus 12 into 3, that is also clockwise. Next is 10, that is also acting downward direction. The perpendicular distance is 3 plus 1, 4 meters. 4 meters. It's also towards A rotate. It's also clockwise. Therefore plus 10 into 4, also clockwise, which is equal to 0. Now plus MA, which is equals to minus 32 minus 40 minus 36 minus 40. So to the sum of all these things, we are getting the value of MA. This is the value of MA?
Minus 148.
148. 40 plus 40, 80. 80 plus 32. 80 plus 32, that is 112 plus 36.
148.
148.
48.
It's a moment. Kilonewton meter. What negative indicates? The reaction in anti-clockwise direction. So the actions are clockwise. Obviously the reaction is anti-clockwise. Initially we assumed a clockwise direction, but actually that is anti-clockwise direction. Just indicating value. Don't go and change and don't do once again. Just we have found that value. The MA is anti-clockwise 148. VA is upward 74. HA is 0 because there is no existence of horizontal forces. So this is the example for cantilever type of beam. How to solve cantilever type of beams. Next, let's move on to second type of beam, that is simply supported beams. Simply supported beams. It's also very, very important problem because here we have given support B is inclined. Support B is inclined and roller. Inclined roller support. So while writing the free body diagram, be careful while support is inclined. So first step, as usual, write the free body diagram. Indicate the support reactions and write all distributed loads into point loads. Clear? Let us move on to the second problem. Here it is hinge. First I will indicate the support reactions. Hinge, how many reactions? 2 reactions. Initially I will assume positive. So hinge VA, HA. At B we are having roller. Inclined roller. It's very, very important. The roller angle. The angle given in the problem 30 degree. So we know that always reactions are developed perpendicular to the contact surfaces. It's an equilibrium concept, we know that. So drop, it's just point B. Drop perpendicular from point B. Perpendicular matlab it's 90 degree. So determine this other angle. 90 minus 30, the angle is 60. So here the same 60 will be equal to the principle of transmissibility, 60 degree. This reaction, what is the roller? How many reactions? Only one reaction, that is VB. Here is an inclined support, right? So resolve this. So when we are resolving, we are getting, this is VB sin 60 and VB cos 60. VB sin 60, VB cos 60. Be careful when we are writing reactions at supports. Support A is hinge, only 2 unknown reactions, HA, VA. Support B is roller, it's an inclined roller. Drop a perpendicular, 90 minus given 30 degree, it gives the 60 degree inclination. By the principle of transmissibility, whatever the force VB here, will transmit at joint, that is VB, the same angle of 60 degree, and resolve this VB cos 60, VB sin 60. So this is the very first step. The next step is distributed loads convert into point loads, inclined loads convert into resolve, into 2 forces. Now, at this point, we are having UDL 25 into 2. Convert, we are getting W into L, 50 kilonewton, and the distance is 2 by 2, that is 1 meter. The remaining this one is also 1 meter. The next is this point. Here we are having inclined point load of 40 kilonewton at 45 degree. Reduce this into point loads, that is 40 cos 45 and vertical downward. This is direction is very, very important towards the joint. So this is 40 sin 45. Next, this particular 30, it's a purely vertical point load, keep as it is. 30 kilonewton. So this distance is also 1 meter, this distance is 3 meter, this distance is 2 meter. This is the free body diagram. Now, this is the first step. Write the free body diagram. In second step, determine VA, HA, VB. That is the ultimate aim of the problem. Determinate VA, HA and VB. Determine VA, HA and VB. Determine VA, HA and VB. The first equilibrium condition, sigma Fx equals 0. All horizontal right side forces are positive, left side forces are negative. Assumption. Therefore, plus HA plus 40 cos 45 plus 40 cos 45 minus VB cos 60 equals 0. Here we are having HA as unknown, VB as unknown, so take this as equation number 1. Equation number 1. Next you take sigma Fy equals 0, all upward forces, summation, treated positive, downward forces treated negative, that is plus VA minus 50 minus 40 sin 45 minus 40 sin 45 minus 30 plus BB sin 60 equals 0. Here also VA is unknown, BB is also unknown. Take this as equation number 2. Equation number 2. Next apply the third equation of static sigma moment at A equals 0. All clockwise moments are treated as positive, anti-clockwise moments are treated as negative. This is the point. At same line of action, VA will not produce any kind of moment. This horizontal force HA is also not produce any kind of moment. 40 cos 45 is also not going to produce any kind of moment with respect to point A, because VB cos 60, 40 cos 45, HA, same line of action with respect to point A. It's not having any perpendicular distance. Hence, HA into 0, 40 cos 45 into 0, VB cos 60 into 0. It won't produce. This VA is also moving in same line of action. That is also not going to produce any kind of moments. But this 50 will rotate towards A in clockwise direction with perpendicular distance of 1 plus 1, 2 meters. That is 50 into 2 clockwise. That is plus. Next this one, 40 sin 45, rotate towards A. The total distance 1 plus 1 plus 1 plus 1, 4 meters, plus 40 sin 45 into 4. 40 sin 45 into 4, that is also clockwise, rotating in clockwise. This 30 is also rotating with respect to A clockwise. 4 plus 3, 7 meter, plus 30 into 7, plus 30 into 7, is also clockwise. But if you come to this VB towards A, will rotate in counterclockwise direction. That is minus VB sin 60 into the total distance is 7 plus 2, 9. Total distance 7 plus 2, 9 equal to 0. Now 50 into 2, how much? 100. Plus 40 sin 45 into 4, how much? 40 sin 45 into 4.
113.13.
113.13. Next, plus 30 into 7. 210. Minus, if you take this side, it will become plus, that is equals. What is the value of sin 60 into 9? Sin 60 into 9. Sin 60 into 9.
7.79.
7.79 times of VB. Now what is VB? VB equals 100 plus 113.13 plus 210 divided by 7.79. Divided by 7.79. How much?
54.31.
54.31 kilonewton. So positive, hence acting upward. So whatever VB value is 54.31 kilonewton and positive. So whatever the direction we assumed up, that is right, positive. Next, once we know the VB value, from equation 1 we can easily compute HA value. That is from equation 1 HA equals minus 40 cos 45 minus cos 40 cos 45 plus VB means 54.31 cos 60. So what is the value of HA? Do this. Minus 40 cos 45 plus 54.31 cos 60 plus 54.31 cos 60
minus 1.12.
minus
1.12.
1.112 kilonewton. Minus indicates acting left side. Whatever we assumed positive direction, but we got negative. No problem. Just indicate here. Clear? Once we know this HA, the only thing is we have to compute VB. Now once again from equation 2, what we did? We substituted this VB value to here. We got HA. Now once again we are going to substitute this VB value to here. We are getting VA. From equation 2. What is the value of VA? VA equals 50 plus 40 sin 45 plus 30 minus 54 VB 54.31 sin 60. Take this side negative. We take this side plus. Take this side plus. Take this side plus. So what is the value of VA? Compute the value of VA
61.25.
61.25 kilonewton. So positive, acting upwards. So this is the ultimate aim of the problem, that is compute reactions VA, HA, VB. So we computed using equations of statics. So very simple steps. So the thing is, sometimes in problems they may give compute magnitude and its inclination with respect to point B. So magnitude and its inclination, inclination with respect to B, joint B, point B. So we are getting the thing is FB equals square root of VA square plus that is this one, right? VA square plus VB square, that is magnitude, vertical reaction. Clear? Or sometimes hinge, HA, we are getting HA. So this is not required as of now, because the ultimate aim of the problem is to compute the reaction. So you just leave over here. Let's see, we take separate problem to compute those kinds, how to compute magnitude and its inclination. So here the ultimate aim is to determine the reactions VA, HA and VB using equations of statics. So the primary thing is, first write the support reaction, next convert all distributed load into point load, next using equations of statics determine those unknowns. Clear? So we discussed two kinds of beams, one is cantilever, another one is simply supported. Thank you.